Now in this video, we will discuss some typical problem of principle of mathematical induction. So before we start, if you like my video, please do like and subscribe. Thank you. Now, here is the first example. Okay, prove that for all n belongs to n, the question is cos alpha plus beta plus cos alpha plus 2 beta plus and so on cos alpha plus n minus 1 beta, that is equals to cos alpha plus n minus 1 by 2 beta sin n beta by 2 sin beta by 2. Just look at the size of the question. Okay, so again let Pn be the given statement. So if Pn is the given statement, see Pn, so this will be cos alpha. So this is the question, cos alpha plus beta plus cos alpha plus 2 beta plus and so on up to plus cos alpha plus n minus 1 beta. Okay, and this is actually equals to cos, you can write this as alpha plus n minus 1 by 2 beta sin n beta by 2 whole upon sin beta by 2 for n equals 1. So now for n equals to 1, see, you take the LHS, this is the LHS, so n equals to 1 means this beta becomes 0, so this will be cos alpha. Actually LHS is cos alpha. Now for the RHS, now this thing is the RHS, this whole thing is RHS. See again n minus 1, this is 0, so this thing is 0, this will be cos alpha, and this is sin beta by 2 sin beta by 2. So basically sin beta by 2 will get cancelled, the remaining will be cos alpha when you substitute n equals to 1. So both are equals to cos alpha. So hence this LHS is equals to RHS. So this statement is true. Now let this statement be true for n equals k. Now for n equals k, true for n equals k, so we can write this. Now statement will be cos alpha plus cos alpha plus beta plus cos alpha plus 2 beta plus and so on up to this is cos now alpha plus k minus 1 beta k minus 1, this is beta, okay, beta, so which is equals to cos, this will be alpha plus k minus 1 by 2 beta, and this is sin k beta by 2 upon, this upon will be sin beta by 2, sin beta by 2, k equals to 1. Now when the statement for n equals k plus 1. Now see, k plus 1, we will take this thing only. See, we will take this thing only, cos alpha plus beta plus cos alpha plus 2 beta and so on up to cos alpha plus k minus 1 beta. Now we will replace k by k plus 1, so that our statement will be this plus cos alpha plus k beta, because k plus 1, that plus 1 and minus 1 will get cancelled. So we have to add cos alpha plus k beta. So what we will do is that we will add this thing on both the side of the equations. Okay, now look. So our equation was cos alpha plus cos alpha plus beta plus and so on up to cos, this will be alpha plus k minus 1 beta, okay, plus this will be cos alpha plus k beta, as I have discussed, alpha plus k beta. Now this is equals to cos, use bracket, so which is alpha plus k minus 1 beta by 2 bracket close sin k beta by 2 whole upon, this is sin beta by 2, adding plus cos alpha plus k beta. So I have added alpha plus k beta on both sides of the equation. Okay, now taking the LCM of this thing, from the RHS we are solving. Now taking the LCM of this thing, this will be cos alpha plus k minus 1 by 2 beta bracket sin k beta by 2 plus, because see LCM will be sin beta by 2 only, sin beta by 2, and this thing will remain like this, plus this will be this times sin beta by 2. So this will be cos k alpha plus k beta into sin beta by 2 into sin beta by 2. Okay, now what we will do is that we will multiply this thing like this and this by 2. So multiplying this whole by 2 will make it 2, 2 and this 2. Basically I have done multiplying this fraction by 2 and then dividing by 2. Okay, now the next step. Now see, this is what? This is 2 cos, you can consider this as A, this as B. Again this is 2 cos, this thing is A, this thing is B. Now the formula that we will be using will be 2 cos A sin B. So I should write the formula. Actually this is the formula which we will be using, 2 cos A sin B. The formula is sin A plus B and minus of sin A minus B, minus of sin A minus B. Okay, so this is what? 2 cos A sin B. So this will be sin A plus B, means this plus k beta by 2. Okay, first of all this thing. So this is sin C. Now watch the steps. Sin A plus B. So this will be alpha plus C. If you open the bracket, this will be k beta by 2 minus beta by 2, and this will be plus k beta by 2. Okay, so actually this k beta by 2 will become k times beta. So this will be sin alpha plus k beta minus beta by 2. Okay, now this is sin A plus B minus of sin A minus B. See, sin A minus B. So A minus B will be alpha plus k beta by 2 minus beta by 2 minus of sin k beta by 2. So that plus k beta by 2 and minus k beta by 2 will get cancelled, and you will left with alpha. This will be alpha minus beta by 2. Okay, again solving for this, plus for this thing, 2 cos A sin B. This will be sin, first of all A plus B. So alpha plus k beta plus beta by 2, alpha plus k beta plus beta by 2 minus of sin A minus B. So this will be alpha plus k beta minus beta by 2. Okay, minus beta by 2. Now this is whole upon 2 sin beta by 2. Now see, this term sin alpha plus k beta minus beta by 2 minus sin alpha plus k beta minus beta by 2, they are same, so they will cancel out. Now we are left with sin alpha plus k beta plus beta by 2 minus sin alpha minus beta by 2. So let's write this. Sin, this is alpha plus k beta plus beta by 2, and this is minus sine alpha minus beta by 2, okay, upon 2 sine beta by 2. Now the thing is, see, now the thing is that we'll use the formula sin C minus sin D. So which is sin C plus D, sin C minus sin D is 2 cos C plus D by 2 into sin C minus D by 2. Okay, so using this formula sin C minus sin D. Now see, this will be 2 cos. Now see, 2 cos, this is C plus D. Now see, this will be alpha plus k beta plus beta by 2 plus alpha minus beta by 2. So if you add a and b, beta by 2 will get cancelled. This will be alpha plus alpha, 2 alpha. So this will be 2 alpha plus k beta by 2. So this will be 2 alpha plus k beta by 2. Okay, 2 cos. And sin C minus D. Now C minus D, see again, this is C minus D. Alpha alpha will get cancelled. This will be k beta plus beta by 2, beta by 2. This and this will add up because this is minus. So this will be k beta plus beta by 2. Sin k beta plus beta by 2 upon 2 sin beta by 2. Okay, so now we just have to rearrange it. Now if you divide this by this, this will be alpha, so this will be 2 cos C, this will be alpha, plus this will be k beta by 2, this will be k beta by 2. Actually we can write this as k plus 1 minus 1 bracket beta by 2, which is the same thing. Okay, now this is sine, we can take beta common, this will be k plus 1 by 2 upon 2 sine beta by 2. Now if you compare it with the equation of k, okay, so this is cos, k is to be replaced by k plus 1. So we have replaced k plus 1 and this was k beta, so which is replaced by k plus 1 beta by 2, 2 sine beta by 2. So therefore pk plus 1 is true. So in this case p, okay, so what we have done that pk plus 1 is true whenever pk is true. So hence from the principle of mathematical induction, the statement is true for all natural numbers n. Next example, prove that, or you can say next typical example, cos theta, prove that cos theta cos 2 theta into cos square theta and so on up to cos 2 to the power n minus 1 theta, that is equal to sine 2 to the power n theta upon 2 to the power n sine theta for all n belongs to natural number. So let Pn be the given statement. So Pn be the given statement. So again we write Pn says that this will be cos theta into cos 2 theta into cos 2 square theta and so on up to cos 2 to the power n minus 1 theta, that is equals to sine 2 to the power n theta upon 2 to the power n sine theta. Okay, now again step 1 will be for n equals to 1. Now for n equals to 1, see P1 for n equals to 1, this is P1. Okay, so we do this. So 1 means 2 to the power 0, n minus 1, 1 minus 1 is 0, 2 to the power 0, which is 1, which is cos theta. So that LHS is actually equals cos theta. Now for the RHS. Now RHS, this is 1. So this is sine 2 theta upon 2 sine theta. So RHS will be sine 2 theta upon 2 sine theta. Sine 2 theta is what? 2 sine theta cos theta upon 2 sine theta. You cancel these two, sin theta will get cancelled. This is cos theta. You see that LHS is equal to RHS. Hence the statement is true. The statement is true. Is true for n equals to 1. Now, let it be true for n equals to k. Now, if you say that let it be true for n equals k. So, that pk, so this pk will be cos theta, cos 2 theta, cos 2 square theta, and so on up to cos 2 to the power k minus 1 theta. So this is equals to sin 2 to the power k theta upon 2 to the power k sin theta. Okay. Now what for n equals to k plus 1? Now for n equals to k plus 1, what we will do is that, see, if you write as k plus 1, this will be cos 2 to the power k theta. So it's on multiplication, so we'll multiply this on the both sides. Or like for, just a second, for n equals k plus 1. So this we can write like cos theta, cos 2 theta, cos 2 square theta, and so on, cos 2 to the power k minus 1 theta into, this is cos 2 to the power k theta. Okay, so which is again, this is equals to sin 2 to the power k theta. So this will be 2 to the power k sin theta into cos 2 k theta. See, basically what I have done is that this was the original equation. So I have multiplied cos 2k theta on both sides of the equation, replacing k by k plus 1. Okay, now solving this RHS. Now we are taking the RHS and we will be solving this RHS, cos to the power k theta. Okay, this all in multiplication. So we can directly write this as sin 2 to the power k theta into cos 2 to the power k theta upon 2 to the power k sin theta. This is 2 to the power k sin theta. Now see, again this fraction multiplying by 2 on both sides, this and this. So this is 2 sin theta cos theta. Actually the formula of 2 sin theta cos theta is sin 2 theta. So this will be replaced by sin 2 into 2 to the power k theta upon, actually this will be 2 to the power k plus 1 sin theta. So this will be sin, I am writing it below, this will be more clear. So this will be sin 2 to the power k plus 1 theta upon 2 to the power k plus 1 sin theta. So actually this is what, therefore we can say that the statement pk plus 1 is true. Pk plus 1 is a true statement whenever pk is true. Whenever pk is true. Hence, from the principle of mathematical induction, this statement is true for all natural number n. So this was the original. See, this was the original, sin 2 to the power k theta. So replacing k with k plus 1. So sin 2 k plus 1 theta upon 2 to the power k plus 1 sin theta. Hence proved.